A friendly welcome to the station number 4, where we will showing the turbine machinings. I will shortly introduce you our team. It will be Mathieu Fabre from the company Emuge Franke from the tool supplying. My dear colleague Roman Kokot from the application side. And all in all has been programmed with him and open mind regarding the turbine disc inside of the machine. So then I will hand over to Mathieu to introduce the machining of the tooling and so on.
Pablo, thank you so much, and also from me everybody, a huge welcome for this turbine machining day and this station number 4, where we will talk about turbine disc machining. At the beginning we will take some time, and that is what I'm showing you on the screen now, about the turbine production cost effectiveness. As you see on the diagram right now, we have here put the parts produced on a time frame, and we see that we have a certain level of cost by the investments at the early beginning, where we have to buy actually some new tools. This investment is high, and after, during the regrinding of this tool, the regrinding costs are going down, and over the time of the production, the cost evolution is going always deeper, always lower, the longer we can mill and produce with these parts. Generally speaking, we were talking about time frame for the production of such turbine disc of, let us say, around about 10 years, even more. But I say, this reality is unfortunately an obsolete reality. Why? I guess you will confirm it is now. We have more something that is looking like this. We have the production of 3 parts of the type A, and after the part type B is coming, which is roughly or rather similar but not the same, which means we need some other tool production, we need some other units, we need some more investments. After the part type B, we have also the part type C, which is coming on the machine. And then the part type A is coming back, and the B, and the C, and so on further on in the production. And the next negative effect we have for the production of our parts is that the lifetime of these parts is not 5 years, is not 10 years anymore, but we are talking about 5 years, probably even less. And that all, as we see with those red lines, with an increasing of the setting time on the machine, which means that we are losing in productivity. Now I will try to make a summary about the consequences. We have first a huge investment in the tooling. It is, in the example or in the scenario I was showing you, 3 times more. And on the time frame where the parts are produced, we see we are producing only 22 parts, where it was 30 with the long-term production business. That means that we have more investments and in less productivity, in less parts. The consequences are we must improve the flexibility and reduce the tool costs. That is the current reality. For us, the solution to reach these improvements and to fit to the requirement you have for the cost of the parts in the production is the multitask machine. Multitask machine like this Okuma machine, where, Pablo, please, explain us a little bit about the features.
Thank you, Mathieu. So I will go back into the multitasking machine, which we have here in the background. At the end, everything is based, or the most important thing is the base of itself. So over here we have a cast iron, rock solid cast iron machine bed. Also here it is a double column construction, so the table is moving between or under the spindle itself. So also here, the most convenient and best situation we can have for the machining itself. What we have from that point of view is that we have the flexibility also here for the single part machining or mass production, is that we will have in the background or the behind of the machine would be the 2 APC, so that the operator always have a full access to the machine and can operate, measure some parts or whatever is needed. Or for a mass production, or we also have some huge aerospace customer down in Poland, which have such kind of machine, or 8 of these machines, combined with an FMS system, which is making very precise, dedicated gearbox housing for the aerospace. So as you can see, it's a high precision machine in this area. What to tell else? The benefit actually what we have here from the multitasking machine, as we had opposite on the Malta side, there we had the turning machine with the milling capability. Sorry. Over here we have a milling machine with turning capability. Over here the C-axis itself, the table, is up to 800 RPM. We have more than 1000 Newton meter torque, so we can really have a high efficient machining of titanium and rough material, which is outstanding in the market. In combination with the 20,000 RPM spindle, which we have at the moment 85 Newton meter torque, so it's a huge variety possible. But that's not the only spindle. We have up to 20 different spindle variations, which the customer can define whatever he's needing. So it's up to your application what spindle we should add to the machine itself. Regarding the flexibility is also that we have 32 tools as a standard. We can have up to 268 matrix magazine, which you can imagine you have a huge tool storage, and it's much better to have these tools in the machine than somewhere in the cartridge and the operator, oh, I need a tool, and runs off and the machine doesn't make any chips at all, which doesn't make sense for these machines. What else to tell on that one is that, regarding the, let's say, some key figures, we have in X 925, in Y, the full range over the table itself is 1050 millimeters. We have in Z 600, we have the swivel axis, A axis, plus 90, minus 120. So also there is, if we have a certain accumulation of chips inside of the part or on the part, we easily can swivel the table with some shower coolant. We have the clean part, so all in all for unmanned production, perfectly designed. When we're coming back actually to the multitasking machine, also here compare that we have turning, we have milling, we have all kind of drillings, etc. We also have the possibility or the functionality of adding the gearbox, the gear package. So we also can have hobbing on this machine, and we also can have skiving even on this machine, which is in the last couple of years very outstanding process, and it's really efficient gear machining. And also here we had some testing for a bigger aerospace customer up in UK, which a diameter of 1 meter, a module 5. So, and they were more than surprised about the quality which we could have on that machine. And if we're talking skiving, skiving is the, let's say, the top class of the synchronization which is needed inside of the machine. As you can imagine, regarding the synchronization of the M spindle and the C axis is the most important thing regarding that, and therefore that as Okuma is producing the CNC, the machine, the design, the PC, the software controller, the drives, and we are the most suitable one which can make the synchronization compared to many of our competitors. Who can synchronize better than if you have all in your hand? Okuma does. Also here the operator-friendly issue, which is the drive of Okuma, and therefore also we have, for example, our intelligent technologies. One of it is called Servo Navi. As you can imagine, we can have up to 700 kilo on the table. Okay, if we have a swivel axis with 700 kilo moving, the acceleration, deceleration will be adjusted to the maximum weight. What happens if I only have 100 kilo? Yeah? We are losing actually the acceleration and deceleration, which the machine could do without destroying itself. And therefore Servo Navi, just by pushing some buttons, automatically will take the torque of the drives and adjust them accordingly to the weight which is on the table. And due to that we can easily increase or decrease the machining time, because the acceleration, deceleration are much more aggressively. And we have even some, they say, examples from workpieces, from customer side, which up to 25% shorter machining time just by pushing some buttons. And even if you have, let's say, massively chip removal, so that you have a workpiece of 400-500 kilo, you have huge chip removal, and the part at the end is only 100 kilo. Even in the meanwhile, in the program, the machine can run the cycle automatically and adjust the parameters. So at the end, again, it's a huge benefit for you and your profit or the output which you have on that machine. What we have also in addition for the intelligent technologies over here is like the thermo-friendly concept, which we also have heard on the opposite, on the Maltes U4000, and we also will hear on the Genus M465AX. We have on dedicated areas certain temperature sensors, which is recognizing the temperature change, and according to the change, the machine automatically will making some, resettings, calibrate, so that the machine will keep, let's say, the micron level in the part. Even your operator will shortly go to a toilet or go for a smoke, and the machine will stand still for 10 minutes or 15 minutes. The machine is still precise as before, which is a huge benefit for you. You have less scrap parts and so therefore, all in all, as we said, the idea of Okuma is we are driven to make the best out of the machine for the operator himself. So enough from the machine itself. I would like to hand over back to Mathieu regarding the machining time, and please enjoy his interview.
Thank you, Pablo. Thank you so much for this information regarding the machine. But once again, I want also to really say, thanks to the development of such machines, we can now also improve the performances of our tools because we have the rigidity and the stability. That is what we are actually proving now on the parts we produce, we prepared for you, where we have several machinings that are we want to focus on. And as a first operation, we want to talk about the fir-tree machining. In a conventional way, the slots are pre-machined with several tools, with several steps, before that the form pre-cutter is coming to achieve a constant wear, a constant stock for the finishing operation. But what we are setting now for you on the machine is the first optimization we can achieve thanks to such kind of modern machines. And that is the combination of the operation 1 and 2 in only one tool. The tool that we see now on the screen, this conical pre-cutter with cylindrical part, which has the possibility, just because of the setting of this one tool instead of two, to reduce the machining time, to improve the productivity of more than 7%. Just because we are using one tool and then turning the pass less, we are saving time. A very easy solution that is given thanks to this modern machine. The tool set over there is a technology that we have proven since years with our standard range to program multi-cut, which we are selling. It's definitely one of our top sellers, and we are selling this kind of tools all around the world since years. The patented multi-cut routing profile that we see described now on the screen has the advantages to be very strong. We are even increasing these performances thanks to the stabilized routing profile. You see in the front part of the rake angle, we have ground an area just to be sure that we are optimizing the cutting edges and the wear building on this edge. And even if we have a strong machine, in such kind of machining, as you can see, the part could be unstable. And therefore, the irregular spacing is giving the additional smooth milling process, which is giving us the possibility to mill vibration-free. But as you can hear now, the routing cutter, it's what we call a man cutter, a cutter for men. It's this heavy-duty machining, and we are now paying attention on this routing pre-machining operation, which the main issue or the main topic of this tool is to reach a constant stock for the finishing operation and being sure that the surface quality and the accuracy of the profile is matching the customer requirement. Conventionally speaking, a third tree cutter is produced with a grinding wheel, which is actually making, on this example that I'm putting you on the screen, 4 teeth. And the reason why we only have 4 teeth is because the grinding wheel has to go through the slot. And because of that, there are areas on the tool which are just removed, not because we need it, but just because the grinding wheel have to go through. Actually, on the third tree cutter, like we see on the screen, the only area that is really a function area is delimited by this blue line. That is the cutting part, the efficient cutting part of the tool. So let's just think about an option of making this core diameter larger, making this flute just as deep as we need. That is actually the PAGODE design. And in the example, as seen, instead of 4 teeth like we had, we have an increasing of the teeth quantity up to 8 teeth. So the quantity of teeth is doubled in this example. This development for the PAGODE finishing cutter was so successful by the customers that they asked us to come on the routing process. And that is the tool that we have seen right now, where actually the differences between the routing PAGODE and our profile and the PAGODE finishing cutter, the end profile, the main difference is, of course, for the routing profile. We need more space in the flute. The flutes are deeper just to be sure we have enough space to remove the chips. We have a core diameter which is much larger than the current design, and in this case the current tools with the conventional geometries have only 3 teeth. So we have an improvement of the teeth quantity, which is a benefit in the production time, in the feed, and also in the tool life. With this new routing cutter, the first trial results we had have been proven with a performances improvement, with a evolution and improvement of the tool life with a factor of 3, and with a feed rate of 3 as well, which means we can mill faster and we can mill longer. But as said, after the setting of this routing cutter, I told you we will talk a little bit about the finishing cutter and the reason how we came to this technology. The partner, a big German energy supplier in Germany, asked us to develop some finishing cutter to increase the tool life, to be able to have less tools. And that was actually this idea of making a flute parallel to the form, to be sure we have just the requested depth of cut. With this geometry improvement, some performances with tool life improvement, let us say between 5 and 10 times more tool life, have been proven. Which means actually, and that was one of the requests we were talking about at the beginning, a huge reduction of the tool costs. That is actually stupid and a pity for us, because instead of selling 10 tools, we are selling 1 or 2 only. But once again, to be sure we are keeping those industry on such kind of machine, it is a strategical point that will reduce the cost for the tools and the productivity. Here we have the proof that the tool life improvement is the solution to reduce the tool costs. And because of the teeth quantity improvement, the productivity is also extended. A factor of 1.5 to a factor of 2 is possible with this PAGODE technology, which is now on the machine set and proven. As a conclusion, from our point of view, I would say the new references for the machining of third tree cutter is easily defined in 3 points. The first, we need this conical pre-cutter with cylindrical part with the multi-cut geometry. With this solution, we are able to reduce strongly the machining time because of milling in 1 step only. After, as a step number 2, the routing pre-cutter with an R profile is the solution to achieve a constant stock on the full profile and being sure that the PAGODE finishing cutter, the end solution that we have now on the screen, is just making the surface quality perfectly fitting to the requirement and, of course, the form accuracy. With these 3 tools machining step, some productivity improvement with up to 66%, which means only a third of the requested time in the prior manufacturing process is achieved, is reached and proven. And this PAGODE patented made in Germany technology, and by the way, I like to make this small joke and say how nice it is to see this success teamwork between made in Germany and made in Japan. Thank you so much, Pablo, for the nice and good teamwork we achieved together. That are the performances we can reach together. But the good thing is, there are some further productivity improvement possibilities. I remind you that we are talking about a 5-axis machining, actually, where we can mill or machine on any faces of the parts. And after the nice demonstration of our third-tree machining process, we can see on the peripheral we are making some cavities are milled with some standard tools of our program, top cut geometry. And with the same tool, with the routing process, thanks to trochoidal milling technology and thanks to the programming system of OpenMind, the same tool is set for the routing and for the finishing operation. But we can even go further with the standard machining with this kind of multitask machining. We can also mill the earth gearing process, which is requested to combine two parts together. This can be made also with the standard item that we have directly on the same machine. Further improvements in the productivity could be also achieved with the setting of some a drill operation. Even if it is with an angle, this operation could be made thanks to the position, as you see, of the table, and we can drill right now with the solid carbide solution, our AF drill program. And the next tool we set now is our AF drill modular, which is actually a solid carbide head built in an HSS body. At least we can also improve the productivity and the quality of the parts due to the repetibility of the deburring operation, thanks to this NC deburring operation where our standard tools are set on the machine. So that was the part that we prepared for you. I hope that all those information were successful, and I wish you a nice day with the next operation, with the next demonstration we have prepared for you, and I thank you for the time you have spent with us.